Okay, so today we're going to be doing more curve sketching practice. The questions you're going to have in front of you that is in the note packet that I asked you to print out here, I'm going to go through one by one with you, and then the other one is going to be the homework. These questions are very, very, very similar to the questions you would experience on the AP exam next year in the multiple choice section. In the multiple choice sections, there's two types. There's a part that has multiple choice without the calculator and another part that you can use a calculator. So here I have a mix of both. So we're going to be, it's more heavily on non-calculator, but there is one question here that you have to use a calculator. But regardless, these are the questions that you should become familiar with, because this is how you'll see it next year questioned on your AP exam. Okay, so for the first question, they're saying how many critical points does f of x equal, and they give you the equation, have. Whenever they're just using the vocabulary, critical points, okay, that's referring to the first derivative set equal to 0, the first derivative undefined, right? Even though you might hear people talk about critical points being points of inflection, which comes off the second derivative, if they just say critical points and that's it, they automatically are referring to the first derivative. So therefore, you're just going to go ahead and find the first derivative of f of x equals x minus 1 cubed times x plus 4 to the fourth. And the only way that you can do this is with product rule and chain rule involved. So we're going to go ahead and say, okay, the first derivative, the derivative of the first function is the chain rule. So 3 comes in front, x minus 1, drop that down by 1, times the derivative of the inside, which is 1, times the second, plus the derivative of the second, and what you're going to do is set it equal to 0. But again, I see that this is pretty complicated, so I'm going to clean this up. And I'm going to see that I can GCF an x plus 4 out. And I'm going to take out the cubed, because that's the lowest out of the two. I can also take an x minus 1 out. And I'm going to take an x minus 1 raised to the second power, because that's the smallest out of the two. So when you do that, that's your GCF. What's left? You have this 3 still there. The x minus 1 squared goes away. The 1 obviously gets absorbed. And then I'm left with 1x plus 4 to the first power, because I divided this out, subtracted those exponents. Plus this gets 4. This crosses out with this. And the 1 gets absorbed, and we're left with x minus 1 to the first power. All right, at this point, you should be coming comfortable with that. Here, I'm left with the first derivative is equal to, we have x minus 1 squared, x plus 4 cubed, and in here, this becomes, I'm just going to do that work over here in a different color. So you see that this is 3x plus 12 plus 4x minus 4. So we're left with 7x plus 8 equals 0. Now I'm going to set this whole first derivative set equal to 0. And when I go ahead, this is already factored. So I'm just going to get x minus 1 squared equals 0. So you get x equals 1 there when you square root it and solve for x. X plus 4 equals 0 cubed. You're going to cube root both sides. You're going to get x equals negative 4. And 7x plus 8 equals 0. X equals negative 8/7. Okay? So how many critical values? Now, I didn't ask you if I have max or mins. These would be critical values that I put on my number line. So my answer is, I have, the answer for this one, for 1 is C. I have 3 critical values. Definitely. Now they might not be all max and mins. That would require me putting this on the first derivative line, but I'm not going to. The question was just how many critical points do I have? Does this function have? And the answer is 3. Okay, moving on. And the most important thing that I want you to get from today's video is understanding the vocabulary and exactly what the question they're asking. So here they go ahead and say, okay, the f of x is given to you. So always take note where you are on that function q that we've talked about, f of x. And they want to know is decreasing. They want to know when this function is decreasing, on what interval. So I know decreasing occurs when my first derivative is less than 0, okay? So that's what I'm going to be looking for. So what I first need to do is take the derivative of this, and I'm just going to get 8x cubed plus 8x. I'm going to set it equal to 0 to find my critical values, and I'm going to have a GCF of 8x, and that's going to come out, and I'm going to be left with x squared plus 1 equals 0. I'm going to get 8x equals 0, so x equals 0, x squared plus 1 equals 0. And when I minus that 1 over, and I square root it, I'm going to get an imaginary. So there's no critical values from there. I only have one critical value, 0. I'm going to test into the first derivative. So I'm going to, I know my first derivative is factored is 8x, x squared plus 1, and I'm going to test -1 in here, which makes that negative. And then -1 squared is going to be positive plus 1. Well, this section is always going to be positive. Well, that's going to give me a negative. So in -1 section, it's negative. And then if I plug in a positive 1, that's a positive. And then this is going to stay positive. So this section would be positive. So my answer was asking me in what interval is this f of x decreasing. It would be from -infinity. So the answer would be -infinity to 0. So again, the answer C, from -infinity to 0. First derivative is always inclusive. Okay, moving on. And if I'm going too fast, you can pause me, try it again yourself. And honestly, you could always be trying these ahead of time and then just pressing play and seeing if we match up. Okay, so for what interval is f of x equal to 1 minus x squared increasing? Again, the key word here is the word increasing. F of x increasing. Well, f of x is increasing when f prime, so I'm just going to write myself a note, f prime is greater than 0. So I need to go ahead and find the first derivative. Now here, a lot of you might want to go ahead and do quotient rule, but not necessary. I don't have a variable in the numerator. Please get comfortable in going and rewriting this. I can rewrite this as 1 minus x squared to the -1. I just brought that whole denominator up. And now I take the derivative using chain rule. So this goes in front, -1 minus 1x squared. Drop this by 1, so I get a -2. And the chain rule is the derivative of the inside. So derivative of the outside is taken care of here, times the derivative of the inside, which is -2x. So now I just go ahead and clean it up and get rid of my negative exponents. So this whole expression will go in the bottom, and you get -1 times -2x. It's a positive 2x with 1 minus x squared squared. So that's my first derivative. I want to know where that's increasing. Well, I need to find my critical values. So when I go ahead to do my critical values, you're going to first see when it's undefined. When is the first derivative undefined? So 1 minus x squared, that's going to happen if the denominator is equal to 0. I square root this. I get 1 minus x squared is equal to 0. Then I add the x squared over. I get 1 equals x squared. Square root both sides. I get x equals plus or minus 1 as undefined values. Okay, that's critical value. So I'm going to go ahead and say, okay, first derivative, I have a critical value at -1 and 1. What about when the first derivative is equal to 0? Well, that happens if you have a rational function. You're going to take this, set the first derivative set equal to 0. If you cross multiply, or you just know that a fraction's only 0 when the numerator is 0, you're going to get x equals 0 is another critical value. Okay, so now we need a test. So we go ahead and we try to test into the first derivative. So I always like to have a visual. So I write the first derivative right there, and then I pick a number. I'm going to pick -2. If I pick -2, that numerator becomes negative. So this is me testing this at -2. Now, I could plug in whatever number I want here. It's going to become squared. I'm going to get something. It's always going to be, if I square the whole denominator, well, that denominator is always going to be positive. So here, a negative over positive, that's a negative. So now I'm going to try f of -1/2. Okay, well, again, -1/2 times 2 is still going to be a negative on top, with the positive always being on the bottom. So that, again, is going to be negative here. And then the next one, if I try +1/2, well, that's going to become a positive over positive, and that's a positive. And then a +2, well, that's going to be, I'm testing this section here, it's going to be positive over positive, so that's a positive. So now the question went back to, in what interval is it increasing? Well, I know from 0 to 1, and 1 to positive infinity, okay? Now here, why could I not make it inclusive? I had to separate it and make it not inclusive, even though it's the first derivative, because these values were undefined, okay, from the original function, okay? So if you looked at this from the original function, it's undefined. If this was not, if the original function was not undefined at 1, you technically would have been able to say from 0 to positive infinity. So the answer for this one would be choice C, again, C, right? Hopefully we're following that, moving along, okay? Just checking my time there. All right, let's look at number 4. Okay, number 4 is the only calculator question on here. First of all, how would you recognize a calculator question? It's going to be in the calculator section. Also, you're going to see a bunch of decimals. Okay, anytime you have crazy decimals, that's usually telling you that this is a calculator question. Let's read it. It says if f prime of x is equal to, they're giving me the first derivative, so just take note to that. Your first derivative is given to you. They want you to approximate the location of a relative max. Okay, so here comes the instruction for this. I'm just checking my time. I don't want to run out. They're saying there's a window of 0 to 6. So whenever you're working in calc, okay, you no longer, your mode should always be in radians. You should no longer have your mode in degree. Then you go ahead and you type in that first derivative. And then they told you your window, 0 to 6. So you change your x min to 0 and your x max to 6. And then you graph it. So there's my graph, okay, in the blue. So what you want to see is I just wrote this here. This is the graph of the first derivative. Well, remember, I always told you, hey, instead of trying to interpret that, you could go ahead and say, okay, there's a critical value somewhere around 1, and this is 1, 2, 3, 4. So so there's another one at between like 3 and 4, right? So let's call this 3, blah, blah, blah. And this is almost close to 1. Well, you know it's negative here because it's underneath the x-axis, positive here, and then back to negative. If I'm looking for a max, you're looking for the first derivative set equal to 0, so those are your x-intercepts, and a change from plus to minus. So if that's happening right here. I'm going to stop this and move on to the next video.